So let's look at experimental probability. Experimental probability is what happens when you actually perform an event or an experiment, such as recording the results when flipping a coin 50 times. On the other hand, we have theoretical probability, which is only what could happen. So flipping a coin, you would have a 50% chance of getting heads. But the more you perform the experiment, the closer the experimental results will get to the theoretical probability of 50%. Remember, experimental probability is actually what really did happen when you performed the experiment. So here we have the results of flipping a coin. Landed on heads 8 times and on tails 17 times. What were the experimental results of flipping a heads? Remember, to find probability, it's success over total. So we had success of 8 times of getting a heads. So that would be 8 out of 25 times. You divide the numerator and the denominator, so 8 divided by 25, to get the decimal probability of 32 hundredths. For the percent, you can think, well, 32 hundredths means it's out of 100, which automatically makes it a percent, 32%. In this experiment, we have a bag of marbles, red, green, and blue. A marble is randomly drawn from the bag, and then its color is recorded on the frequency table, and then it's put back into the bag. This is repeated a total of 30 times. Here are the results. Pause the video and find the fraction, decimal, and percent experimental probability of drawing a red marble. Remember that we drew a marble out of the bag 30 times, so there's our total. We picked a red out of the bag 3 times. 3 out of 30 simplifies into 1/10. Well, we just said it out loud, which means there's our decimal, 1/10. We can use our place value of the tenths. And then as a percent, we could write it as 0.10, which is 10 hundredths. And 10 hundredths, if it's out of a percent or out of 100, you automatically know the percent, 10%. Now that's the same as multiplying by 100 to move the decimal place 2 place values over to get 10%. So let's just think for a little bit about how that compares to the theoretical probability. Theoretical is only what could happen. There's 1 red marble out of 3 marbles in the bag. 1/3 is 0.3 repeating, 33%. Every Thursday, Kyle dines at his favorite Chinese restaurant. For fun, he keeps track of the fortunes he receives in the fortune cookies, so he puts those into categories of health, wealth, family, friendship, and advice. So the categories of his last 48 fortunes are shown in this table. To the nearest whole percent, what is the experimental probability that the next fortune he will receive will be in the category of friendship? Probability is success out of total. It was success of friendship 6 out of 48 times, which simplifies to 1/8. Dividing numerator by denominator, we get 0.125, rounded to the nearest hundredth would be 13 hundredths. 13 hundredths, if it's out of 100, that is a percent, 13%. Here we have the exact same scenario, except we're going to find the experimental probability that the next category will be for health. Pause the video and find the fraction, decimal, and percent probability of getting health. So the fortune cookie for health was 8 times out of 48, which is 8/48, which simplifies to 1/6. When you divide numerator by denominator, 1 divided by 6, you find it's 0.16 with 6 repeating. Rounded to the nearest hundredths, 2 places out, like 100 pennies in a dollar, is 17 hundredths. As a percent, 17%. Now think about how this compares to theoretical. Let's say that there's an equal number of each fortune created at the factory in those categories, those 5. To receive a health fortune, it would be 1 out of 5, which is 2/10 or 20%. Remember, theoretical is different than experimental. Theoretical is only what could happen, not what actually did happen.